Everybody can hear me? Yeah. Okay. Can you see my screen too? Thank you. Um, I will wait the student until 10:33, and after 10:33, I will start the lecture. I will wait for a student coming for the 3 minutes. Okay, let's start. Uh, let's start this practical session. I'm Tia Yunsu, and today's session is about word-to-back. Today we will cover implementation of word-to-back, uh, especially skipgram. Starting from tokenizer, and we will build vocabulary, and then we implement skipgram and skipgram with negative sampling. Uh, in the next session, we'll use some sentence piece library, and we will learn how to use sentence piece package, and we will visualize word to back and the results. Similar to the other practical session, in in this lecture, do you have any questions? Feel free to ask me, and let's start word to back. Okay, so let's start from word to back. In this session, implement all we will implement word to back from very basic building block. So for this, first import all the Python library which we will use in this session. Just run the code. Okay. And we will implement the tokenizer in this session. We will implement the tokenizer, very basic tokenizer, which we'll call it as white space tokenizer. It requires only two functionality. First one is to break the sentence into the word whenever it encounter the white space, and then return the list of the word. I will show the example. If there is a sentence like I am a student, the output would be like I am a, student. So something like this. And the next requirement is the punctuation mark. The punctuation mark is here, period, comma, exclamation mark, and question mark. And they should be tokenized into the independent token like this. If there is high and period, the return would be the high and the period. So this is the only requirement of the tokenizer, the two things. And so I will give you 5 minutes to implement this tokenizer function. And for this code, you can use regular expression. If you want to use regular expression, you have to import like, yeah. In this session, we will do the code like this, not the NLTK tokenizer. Today's session, we will do first one is white space tokenizer. Okay, so uh, you just write the tokenizer as a script, and like you can use or replace or whatever, but just feel free to write it. But you have to test your own tokenizer by this code, and if you write your code very well, you will see the test passed. So I will give you 5 minutes to do it. After 5 minutes, let's check together. Okay, let's check the answer together. Uh, Today we will not gonna use like NRTK tokenizer or something. We use like write from scratch of the code. And first I will change my runtime and run. Okay, let's check the together. So I do like this. This is read.sub is same thing as Python native function named replace. So it replaced four punctuation mark with white space on the left and the right hand. So resolve to all the punctuation function, and we have to uh and if we encounter a white space, we have to return list of the words. So the sentence is gonna be split like this to make a tokenizer. And so I think this is my code, and I will check if it run. Yeah, I think it runs well because I see the test pass. Everybody do work their code well. You can see the test passed too. Okay, I think everybody can follow this. I will move the next part. Next part is the building a vocabulary. So in this session, we will build the vocabulary for the further use. I write some requirement for build the function. Input argument is a sentence and input and min freak. Sentence is the list of the sentence that build the vocab, and each sentence is the list of word and the output of tokenize. Because we output of the tokenized function is the list of the words. And min freq is the minimal frequency of the word that we have frequency less than threshold are excluded from a vocabulary. This is because we try to handle rare words which occur generalization issues. And we will return three dictionary. First, IDX 2 word, and word to IDX and word freak. IDX to word is a dictionary which map an index to word, key, and value like this. And word to bag map the word into index, key, and value like this. And word freak is which map to word to frequency like this. So you can check the key and the value in here. I will give you 5 minutes to implement this build vocab function. And after 5 minutes, let's check together. As same as this tokenizer function, if you finish to implement this function, you can check your code is right or wrong, like wrong. If your code is right, you have to see these output. So I will give you 5 minutes. Let's start it. Okay, let's check the answer together. Okay, so this is my build vocabulary function code. And first, for concat all the list of words into the single list, so I use the code like this. There is the asterisk. It means it passes the element of the sentence to the function chain. And there might be someone like use asterisk, double asterisk. It means if the sentence is a dictionary, then it passes the argument as the name becomes a key and value will be the dictionary. But in this section, it's not the important thing, so I'll say very briefly. But if you have more question about the meaning of the asterisk, I recommend you to see the document. What is the meaning of the asterisk? And uh, I will I will make a count dictionary, the word freak. I will use the counter, which is the collection library. It counts the occurrence of the element in the list and it returns the dictionary. Key is element and the number of occurrence will be the value. So, okay, let's build the vocabulary here. So iterate over each word, its frequency, each word and its frequency in the word freak dictionary like this, and filter the rare word to avoid generalization problem caused by low frequency word, and add the vocabulary if it means the mean frequency threshold. So, and assign the next available index to the word in both dictionary, word to index, index to word, and word to index. Okay, so, but if the word frequency is below to the threshold, it as a rare word, I will remove this rare word from the frequency dictionary to keep only a significant word. So for remove the word, I'll use this pop and the accumulate the frequency of rare word to assign to the UNK later. This is for use for unknown words. Okay. So this is the code for the building vocabulary function. I think everybody follow it. I will give you 30 seconds to check this code. Okay. I think everybody can follow the practice this session. And if your code is well written, you can see the output like this. Okay. Okay. Let's move on to implement the skipgram. So we also prepare the input for the training word back. As you see the code block, you'll return the tuple. That's the center word and surrounding pair with the skipgram. So I will explain more about function and in the example. The function receives two input argument, token and the window size. Token is the sentence where center word and surrounding word come from. And window size is the number of the neighborhood. So as you see in the figure, if this is the center word and skip window is 3, in the left side is the 3 word, and right side distance is 3. Okay? So token is the so this is the skipgram and window size image, and the output is the window pairs. So I will explain this window pair with the example. For example, let's assume the function received a sentence like John's book is not popular. And the output size is, we assume the output size as 2. The center word may be John. This is the first word, and there is no word in the left side. So there is the window size is only the right side. So output gonna be John's book and John is. Okay, I think this is the very briefly explain of skipgram, and I will give you 5 minutes to write the get window pairs function. And after 5 minutes, let's check together. As the like this, with prior codes, you can test your own code by this test input data. If your code works well, you can see the output like this. So I will give you 5 minutes. Let's check together after 5 minutes. Okay, let's check the answer together. So this gonna be the answer. And I will explain this code. Iterate over the sentence by its index and the token, and calculate the start of the context window, ensuring it does not go below the index 0. Okay, and we have to find end, so we do the code like this, and the end would be the mean with the start length of token. The remaining job is sliding from start to end and excluded the current word from pairing with itself and append the form pair to the window to the list. So it is the code for get the pair. And after this code, you will see the output like this. If the center word is John, the surround word would be the book and is. And if the center was book, the surrounding word is John and is and not. Okay. I think everybody is understand this code because this is pretty easy. And in this section, we will implement the negative sampling function to improve the skip gram. Here, so the negative sampling function should be the sampling the word from the probability distribution. Your job is to prepare negative sample function, and input argument is the power, which is 0.75 in this figure, this part. Okay. And word frequency is a dictionary implement of we implement. This turns that occurs the word. Your job is negative sample to generate negative sample table. Actually, it does not return the actual output. It just assign the output of attribute. I will give you 7 minutes to implement negative function, and after 7 minutes, let's check this implementation code and the whole codes very briefly. I will explain the important thing of this code. So I will give you 7 minutes to implement the negative sampler function. Hey, write your own code, please. Okay, let's check the answer together. Okay. So first, let's see the class of skipgram data set together. So in the skipgram class, there is pet token index, unknown token, and unknown token index. And I will tell you this code briefly. And first, initialize document window size, min freq, and negative sampling gonna be the first. And document is the list of the sentence, and window size is window size, and minimum frequency. This is false. Okay. And we will tokenize into the word and collect the token here. We also apply the build a vocab function. This is the code we make here, build function, right? Build vocab. So, and build vocab to word to IDEX to word and word to index and word freak. Return the three things. And if we want to do the negative sampling, we construct the negative sample table and prepare some items in here. And also we prepare the data for training in here. So this is the class, and let's check the answer for the prepare the negative sample. First, the vocab size is the length of the word freak, because the word freak dictionary contain all the vocabs, and the power is 0.75 as you see in this figure. And normalized constant. Let's calculate the norm, which count the word appearance in the word corpus. This is the same as the here in this figure. And then let's define the table. Table is size is the arbitrary number, so I will write this. But you can feel free to write other number, not this one. This one is not always correct. You can use other words, but I will use this because this is the arbitrary large number, and we will assign the table with the numpy array with 0 like this code, np.zeros. Yeah, and then update the cumulate probability with normalized word probability. And if the probability reach the count as same as here in this figure, we instantly terminate the while loop, and we keep the index to the table just like this. Okay. This is the implement of negative sampler function. And let's see the negative sampler function. It is for random sampling from negative sample table. I believe you can just implement negative sampler by very easy because it is random function like this. So after this code, the probability distribution follow this figure. So, and it's simple, just the prepared data, just return the center word and surrounding word. I think it's easy. And if you do the negative sampling, the output would be the center word and surrounding word plus negative sample with the number of k. So this is the code and this is the sample document. And let's prepare data like this. BB equal. Let's define the dataset class. Skipgram dataset document and window size is 3 and minfreq equal 1. Okay. So everybody follow here. Also, if you have any questions, so there's no questions, I will move on to here. Move on the next chapter. Next part is training the skipgram without negative sampling. In this section, we will implement object function in the skipgram, and the object function is the softmax over a center word and surrounding word. I think this is pretty easy. So to define the loss function. So I will give you only the 5 minutes. After 5 minutes, let's check this code. I will give you 5 minutes. Okay, let's check together. Okay. Uh, okay, this input feature is a tuple of the center word indices and surrounding word indices. So split them into input index and target index. Before mapping index to the latent space, you do like this and obtain the logic with the matrix multiply with the input embed. This in sum is doing the same thing with the torch.meml. So you can use in some or torch.meml, you can choose one. For this code, I will use this one and use the cross entropy loss here to define the loss function and calculate the loss with the logit and target index. I think it's very simple code and everyone can follow this code. So let's test this, see the loss and approach. And we can see the loss and the approach that our model works very well. And last part of the first session is a skip gram with negative sampling. In this section, you will do the same thing as before with negative sampling. Everything same as before, input embedding, output embedding. But input feature is quite different. Center word indices is same, but surround word is a bit different because it concat the negative samples indices, so the shape would be the batch by K, which we use of dataset class. And please aware the index word of surrounding word would be the 0. So it is pretty similar with the prior code, so I will give you 3 minutes to implement the code. One different thing is surrounding word contain negative sample indices. So I will give you 3 minutes. After 3 minutes, let's check the answer together. Okay, let's check the answer. Skipgram with negative sampling. This is pretty easy, I think. So everything is same as before, mapping the latent space with the input index and consider the negative sample and ground truth surround word. Just we consider this and do the cross entropy loss. So the different thing is this, and it reserves the batch size by number of the negative word. So this is the different thing. Okay. So output of is the batch by number of negative words. And this is the use the same as cross entropy loss. This is same as this code we see before. And logit and apply all 0 as a label and calculate the cross entropy here. So I think this is almost same as here. So I'll quickly move on the next chapter. Before move on the next chapter, see, we can train this code and see the loss like here. So I think our code works well. And let's move on the sentence piece and word to back. I will introduce briefly because it's very basic library, and I recommend Hugging Face word tokenizer because it contains many other functionality, not just tokenizer. It contains like BPE or other things. So in this session, we will use a very basic tokenizer named a sentence piece. So first, you install all the library and import NLTK here. Now we will use the NLTK tokenizer and download the movie review dataset. So, and import the use required package like Word2Vec library and Disney, and this we will use in this session. And please set up the parameters. The parameter is non-feature. This is embedding vector size is 300 and negative is 10. This is network for negative sampling and mean word count is 10. This is mean words in one sentence. And the context window size is 5 and output is 5 and downsampling is 0.75. This is like low frequency for high frequency word. And then let's prepare the data set to positive data and negative data for the data and prepare it like this. Okay. Okay, and let's training. I think the train time is 5 minutes, I think. So we do not wait for training and see just result here. So after training, you will see the results like this. Find the similar word to the man. Uh, so you can see the boy, woman, person, guy, teenager. This is a similar word to the man. The most similar word is the boy. And you can see this uh, I will not show you the answer of this, but if you want to see the key to index, you can use the code like this and use key bar to bar index. And then calculate a new vector by subtracting the embedding of king from man from king and adding the queen. Find the top 10 words in vocabulary that are most similar to the resulting vector here. This is the answer. King minus man plus queen is the similar top 10 word is king, queen, sir, fisher, Nichols, creator, co-stars. You can see like this after training this code, but we do not training in this session because it takes a long time. And you can see the similarity of each word to calculate the vector similarity. So the man and woman's vector similarity is 0.767, and uncle and aunt similarity is 0.78, and the similarity of king and queen is 0.67. So you can see the similarity of each word by these codes. Also, you can visualize which word is similar each other with the Disney. I think in other practical session we use Disney a lot, so we skip the code and we see just the result of the code. So this is the visualize of whole word of Disney by this code. And we can also visualize the subword with Disney code. And as you see here, we know this is down, this is eventually, we know the word meaning, but the subword cannot see easily. We don't know what is then and the distance of a bit because the subword does not containing the meaning. So it is hard to capture the meaning than this whole word. So I think it is very easy thing. So after the session, I recommend you to see this code one more time, and you can know all the word to back practical code. So I think we end this class. If you have any question, feel free to ask me, and you do not have question, you can leave this Zoom. So thank you. Okay, thank you. Could you probably a more right answer? Yeah, I will upload this answer after the class. You can see the solution file in CalMS. I think everybody do not have questions, so I will quit this Zoom. So thank you.